Hi there, and welcome to our video. In the last video, we gave some background about data distributions. Today we will see how to do distribution fitting in the software GSS and how to conduct statistical tests to see if data follows a given distribution. Fitting to a normal distribution. We will start with an example from the last video, the body weight of guinea pigs. So a guinea pig weighs on average about 620 grams with some variability, and we want to test if guinea pig body weight is normally distributed. So we open GSS and paste this data into our data table. Then we go to the menu, Statistics, Distribution Fitting, and now we see two options. For now, we just ignore them and leave the one which is selected by default, and then we select our data. Now you already see the data in the histogram here on the right. We now want to fit a normal distribution to this data to visually see if our data could be normally distributed. So here on the left, we select the distribution we want to fit. Here's the normal distribution, and then we press Fit. We can see that the data seems to be well described by a normal distribution. But to be sure, we also want to conduct a statistical test. For this purpose, Shapiro-Wilk's test is the best choice, as it has specifically been designed for testing if data is normally distributed. The other test here, Kolmogorov-Smirnov, is more flexible because it can also be used for other types of distributions than the normal distribution, but it is slightly less sensitive than Shapiro-Wilk's test. Anyway, let's use both tests for now because we want to learn how to interpret results as well. Now we press Fit again, and here is the result. We see that the p-value of Shapiro-Wilk's test is about 0.46. It is larger than our level of significance alpha, 0.05, and hence the data does not deviate significantly from a normal distribution. And we can assume that they are indeed normally distributed. Let's also have a look at the results of the Kolmogorov-Smirnov test. Here the p-value is larger, it's about 0.92. This would again mean that our data does not deviate significantly from a normal distribution, but it also shows us that this test is less sensitive because the p-value is higher. Fitting to several distributions at once. Let's look at a second example, the number of children per household, which we already saw in our last video. Let's find out by which distribution the data is best described. We copy the data from this graph and paste them into GSS. Let's give it a nice header. And now we select Distribution Fitting again. And this time, let's select several distributions to be fitted at once. You can do this by holding the Control key pressed while you click on the respective distributions here in the list. Let's also conduct the distribution test. And now, since we have selected mostly non-normal distributions, we'll just use Kolmogorov-Smirnov test. And now we press Fit. Now you can go through all the selected distributions here on the top to see the respective fits. We can see that none of the distributions describes the data really well. The best fit is obtained by the so-called Poisson distribution. This makes sense because this is a distribution which is often used for count data. And remember, we do have count data, we have the number of children. In a Poisson distribution, only natural numbers are considered, like 0, 1, 2, 3, and so on. This is also the reason why this line looks like a staircase. The Poisson distribution describes our data quite well. However, households with no children are proportionally overrepresented, and this is why our data differs significantly from the Poisson distribution. Cumulative distribution fitting. Now, you remember we have seen this screen before, when we said we would just go with the default selection for now. So the default option is what you would practically always use. However, sometimes data may be available in a different form as so-called cumulative data. Remember the histogram which we saw in the example of guinea pig body weight? If you add the bars of the histogram up from the left to the right, then you obtain a so-called cumulative graph. So this is the meaning of cumulative, you add things up. Now going back to our data, we could also arrange them as follows. Instead of having the weight of each individual, we could create a column with increasing body weight, and in the next column we could add which fraction of all animals had a weight lower or equal to that weight. This fraction could also be shown in percent, however in GSS we use fractions. Now we can select cumulative distribution function here, Then we select the column with the weights for the x-axis, and finally the column for the frequencies for the y-axis. And now we select the normal distribution again and press Fit to obtain this graph. So this was just to illustrate this feature. In most cases, however, you will use the default distribution fitting. So that was everything about distribution fitting in GSS. Thank you for watching, and if you liked the video, please like, share and subscribe.